Good morning, good afternoon, or good evening, Algebra 1, depending on when you are deciding to watch this. This is our second lesson for our new adventure of distance learning. I hope you're all doing well. Hope you had a great weekend. And we're just going to get started, okay? We're going to start by, again, just labeling our notes just so we are organized here. So today is Monday, April 6th. And we are doing graphing quadratics day 2. So day 2 of graphing quadratics. Day 2. All right. It's been a little bit since we talked about this. It's almost been a week. So let's review real quick just some basic things here. So this is from our first lesson. I'm going to start off with a parabola. Remember, that's the shape of our graph. Okay, you with me? There we go. Okay, so if I want to draw in here my parabola, remember your parabola can open upwards like this, or it could be like upside down. Now if we label some stuff on here, remember this point where it turns direction or it comes back around is called the vertex. And this would be a max or a min. This one would be a minimum. What else do we have here, you guys? Let's see here. This point right here and this one right here would be our x-intercept. X-intercept. And remember, those are our solutions, right? Wherever it touches the x-axis would be our solution. So this one would have 2 solutions, 2 answers. We'll talk about that more so later on, like probably on Wednesday. This one has 2 solutions, and we said it opened up. Okay, that's pretty much everything we talked about last week. Now today, we are going to do just some basic graphing. So today I'm going to give you just some really basic quadratic equations, and we're going to graph them. And then we'll just answer these questions about the graph, okay? So let's just start with the most basic. Let's see here, that should be enough space. Okay, let's start with the most basic quadratic function and graph it, okay? So our most basic quadratic function would just be y equals x squared. We actually call this the parent function because all it is, there's nothing fancy we're doing to it, it's just straight up the quadratic function. We're not adding, we're not multiplying it by anything, it's just y equals x squared. And actually, I think we've done something similar to this before. We just plug into a t-chart. So for our purposes today, when you have to graph, you're always going to plug in these 5 values, which we've done before. Here we go. So always use these 5 values. And now we're just going to plug into our equation and see what we get for our outputs. And then we'll just sketch a graph, okay? So, here we go. If I want to plug in -2 for my x squared, so I'm going to have -2 squared. Now you're thinking, remember, if I square something, I'm just taking this number times itself. So -2 times -2 is just +4. That's it. So I'd have the ordered pair -2, 4. If I plug in -1, so -1 squared, so -1 times -1 is just 1. We plug in 0. 0 times 0 is just 0. We plug in 1. 1 times 1 is just 1. And then 2. 2 times 2 is 4. We'll talk about this, but once we graph it so you can see what's happening. But if you notice, you guys, do you see how these match? Like, these are the same, right? And then these points are the same. Because we'll find that a parabola has symmetry. So like these should be the same because they'll be the same distance away from the vertex. And same with these two, they'll be the same distance away from the vertex. So that's a good way to check yourself that these points should be the same. And those two should be the same. Okay, so I know you don't have graph paper, so we're just gonna sketch it. Just try your best. Might not be perfect, but that's okay. We'll figure it out. I'm going to go like 5 dashes over. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 4, 5. 1, 2, 3, 4, 5. Okay. Again, I know this isn't going to be perfect, but we're just sketching it, okay? So if I start with -2, 4 over -2 up 4. 1, 2, 3, 4. So about here-ish. Put a dot. -1, 1. So over 1, up 1. 0, 0. 1, 1. 2, 4. 1, 2, 1, 2, 3, 4. Well, it looks like a parabola. Make sure now you connect your points. There we go. Looks pretty good to me. Okay, now we're just going to answer our typical questions we normally would for our parabola. So what is our vertex? So the point where it changes direction is right here. So that's 0, 0. Now is this point a maximum or a minimum? This would be a minimum, right? Our graph is opening upwards, right? Because it's opening up. So it opens up. Now this is a new word for us, the axis of symmetry. So remember I said, like, look, I could cut my parabola in half and we'll notice that it's the same thing on both sides. So do you see how if I took this line here that goes through my vertex, I could actually fold my parabola in half on itself like this, right? Like, look, this point matches this point. This point matches this one because it's symmetrical. It's like a butterfly. So what is this line that cuts it in half? Well, in our case here, remember, if it's a vertical line, it's x equals whatever number it's going through. So x equals 0. That's our axis of symmetry. And then our last two questions about our graph, our domain. Remember, a domain is always all real numbers. Remember, I can plug in any x value and I'll get out a y value. And then our range, we're thinking, okay, so I go to my vertex. Now, is my graph happening above 0 or below 0? Right, it's all happening up here. So y is greater than or equal to 0. And that's really it today. So the only new thing that we're doing today that we didn't do last Wednesday is the t-chart. graphing what we got, and then this axis of symmetry. Okay, so we're going to do, I think, 2 more graphs together, and then your homework is just like your notes. Okay, so make sure you take really good notes, or rewatch this video, right? Okay, so put that one there. Now we're going to take our basic quadratic function, that y equals x squared. Now we're either going to multiply it by something or add it to something or whatever we're going to do. So we are given to graph y equals half x squared. Okay, so again, I'm going to start with our little t-chart. And we're always going to plug in -2, -1, 0, 1, 2. Those are going to be our 5 values so that we always plug in. And now from here, we're going to plug that into our equation. So the half comes out in front because I'm not doing anything to that. But now I'm going to plug in -2 for x squared. So first I have to square -2, so -2 times -2 is 4. Now what's half of 4? Or 4 times a half is just 2. There we go. Now we're going to plug in -1 for x squared. So again, drop down your half. I'm going to have -1 squared. First I have to square -1, so -1 times -1 is just 1. Half of 1 is just a half, or 0.5. Plug in 0. So now I have half times 0 is just 0 again. Half of 0 is just 0. Plug in 1. Square 1, so 1 times 1 is just 1. Half of 1 is just a half. And now plug in 2. 2 squared is 4. Half of 4 is 2. Now again, let's check and see if we have symmetry. Those match, half and a half. 2 and 2, yep, we are pretty symmetrical. Okay, now we can graph our parabola. So again, draw in your x and y axes here. Again, we're not going to be perfect. I'm going to give myself about, I need to go over 2, right? So I'm going to go like over 3. 1, 2, 3. 1, 2, 3. My biggest number is 2, so I really need to only go up like 3 again. 1, 2, 3. So if we start graphing, I plugged in -2, so I go over -2, up 2. So 1, 2, 1, 2. -1, a half. So I'm going to go over -1 and only up a half. So just halfway between. 0, 0. 1, a half. So over 1, up a half. And then 2, 2. Now make sure you connect it. So here we go. Looks like a parabola to me. It's kind of a wider one. Okay, now if we start answering our questions about this graph. So let's start with our vertex. What is our vertex? Our vertex is 0, 0. Is this a minimum or a maximum? It is a minimum. Does it open up or down? It opens up, or we call it positive, so it opens up. Our axis of symmetry, we'll call that AOS just to abbreviate it, our axis of symmetry. So which line cuts this in half? So at what point does it cut my parabola in half? So think it always has to go through your vertex, right? So pretty much draw that vertical line through your vertex. Now what line is that? What equation is this line? It's x equals 0. Then our last two questions are domain. Remember, our domain is always all real numbers. And then our range. So we're thinking, is my graph happening above 0? Or is my graph happening below 0? It's all happening up here, right? So I want y values that are greater than or equal to 0. Woohoo! We did it. Okay, we have one more and then I will set you free, okay? I just want to do one where you have to multiply and it's negative because it just looks a little different, all right? So this time let's graph y equals negative 3x squared. Okay, so again, start with our t-chart. Plug in our 5 values that we have in. Okay, now we're going to plug in, so I'm going to have negative 3 times negative 2 squared. First square, negative 2. Negative 2 times negative 2 is 4. Negative 3 times 4 is negative 12. Plug in negative 1 for x. Negative 1 times negative 1 is just 1. Negative 3 times 1 is negative 3. Plug in 0. 0 times 0 is just 0. Negative 3 times 0 is just 0. Plug in 1. 1 squared is just 1. Negative 3 times 1 is negative 3. And then our last one, I lied. 2 squared is just 4. Negative 3 times 4 is negative 12. Okay, let's check ourselves. Match, we're good. Match, we're good. So we are okay. So now, since you have to hand graph these guys, it kind of helps if you look at like what our numbers are and what's happening. So do you see how I'm going pretty large in the negatives for my y? So I'm going to kind of set it up like this to give myself some space to graph it. So I'm going to go over about 3 on the x. 1, 2, 3. 1, 2, 3. And then I have to get down to 12 on the negative for the y. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, here we go. Now if we graph negative 2, negative 12, so I'm going to go over negative 2 all the way down to 12. Oops, I didn't mean to do that. 12. Negative 1, negative 3, over 1, down 3, 1, 2, 3. 0, 0. 1, negative 3. 2, negative 12. Looks like a parabola. Let's connect it. Okay, now let's take a minute to answer our questions. So our vertex is 0, 0. It's the turning point of our graph. This would be a maximum point, right? There's nothing greater than that. It's a max. Our graph opens. You see how it's opening downwards? Like our arrows are pointing down. And another way to tell before you even graph if it opens up or down, if this number out in front is negative, right here, do you see how it's -3? That's telling you it's going to open down. Whereas if we looked up here, this was a positive number. See how it's positive a half? So it opens up. A little trick for you. Okay. Opens down. Our axis of symmetry. So what line cuts my parabola in half? Again, that is this x-axis here. So x equals 0. Our domain is all real numbers. And our range, so again, are we thinking is our graph happening above 0 or below 0? It's happening below 0. So I want y is less than or equal to 0. Okay, again, your homework's going to look just like this. Try your best. If you struggle with it, send me an email and we will get you caught up and figured out, okay? Have a super rest of your day or night, depending on when you're watching this, and I will talk to you soon. See you later.